Good morning, everybody. So, on Thursday, I can't keep track of the days anymore. We talked about what happens when oceanic plates meets a continental plate, and how the oceanic plate is more dense than the continental plate, so it subsides or moves underneath the continental plate, causing volcanoes. But what happens when two continental plates meet? That is what we're going to talk about today. It's our continental plates. So our continental plates are made up of all the same stuff. They have the same kind of density. So when two continental plates meet, the ground folds up. So there's folding and crumpling as they are crashing into each other. This is mountains get formed. And here's what it looks like. So on our left, let's say this is the Indo-Australian plate. And it is moving in this direction. And on this side, we have our Eurasian plate. Which contains all of Europe and Asia. And at this part, it is contains basically China. So the Indo-Australian plate bumps into the Eurasian plate and starts pushing against it, creating some of the tallest mountains that we know. And it's not just one layer, but it's pushing up all of the layers. So if you were to cut down through the side of any of these mountains, you would see the layers of the earth. So what this would look like on either side of the mountain range is, here's this layer, and then here's the green layer. The mountain ranges that were created here are the Himalayas. They are so tall because they are so young. So we said plates move apart. So plates can move apart This is divergent. This is when the seafloor is spreading, or when a rift valley is being created, and it makes volcanoes. We said plates can move towards each other. Plates move towards each other. This is called convergent. They are converging, coming together. When they are oceanic and continental, they have subduction zones. And that makes volcanoes. When it is a continental and a continental plate, we have folding and mountains are created. There is one more type of boundary that can happen. Sometimes plates slide past each other. This is called a transform boundary. And transform boundaries cause earthquakes, and fault lines. And sometimes they make mountain ranges called block mountains. The Grand Tetons. In the Sierra Nevada range are block mountains caused by fault lines. Transform boundaries cause earthquakes. We all know that an earthquake, by its name, the earth shakes. But what is it that is causing that? What basically happens is as the plates are sliding past one another, they get caught. GHT. They get caught on each other. Pressure builds up. As each plate is trying to freely slide past the other, they get stuck. They keep pushing and pushing and push harder and harder, and finally they move. That release causes the earth to shake. The type of energy that is released during an earthquake is called a seismic wave. This is the energy released during the earthquake. And it moves out in all directions. Kind of like when you throw a pebble into the water, they move out from the center of the earthquake in all directions. The point where the earthquake starts is called the focus point. Whoops. Ran out of room. The point where the earthquake originates. That is the actual point in the earth where it originates. You all say, oh, but I thought an epicenter was where the earthquake originates. That's only partially true. The epicenter of an earthquake is the point on the surface of the earth. So the epicenter of an earthquake is the point on the surface of the earth closest to the focus, because sometimes the focus is deep within the earth's crust. We measure earthquakes by talking about the magnitude of the earthquake. The magnitude of an earthquake is how strong it is. So the magnitude, how strong is it? Is measured using a seismograph. SEI. And the seismograph measures the shaking of the earth. The unit of measure, or rather the scale that's used to measure earthquakes, is called the Richter scale. And this might be something that you have also heard of. The Richter scale is a 1 to 10 scale. 1 being the least strong, 10 being the most strong. However, for every 1 point, so to go from a 1 to a 2, from a 2 to a 3, 3 to a 4, a 6 to a 7, a 9 to a 10, for every 1 point increase, there is a 10 times as much shaking. So for every 1 point increase, 10, let me say this a different way. For every 1 point increase, the earth shakes. Ten times as much. And releases about 32 times more energy. So the difference between a Richter scale size 6 earthquake and a size 7 earthquake is a really big difference. And just moving up by 1 point on the Richter scale can cause a way lot more damage. The last thing I want to talk to you guys about. Sometimes earthquakes can take place on land, and they can take place out at sea. And when they take place out at sea, they can cause really big waves to happen. And sometimes these really big waves come onto land, and then our little cities are in trouble. When there is a wave that has been caused by an earthquake, it has a special name. We might call them tidal waves, but they are also more known by their Japanese name as tsunami. Tsunamis can occur if the earthquake happens under the ocean. They can be as tall as 90 feet or 30 meters. Which is a 9-story building. They're traveling very quickly. They get very big, and they can cause a ton of damage. So, this is going to be our last set of notes that are going to be due on Monday, April 6th. And on Tuesday, the 7th, I'm going to be doing notebook checks. So I hope you guys all tune in to Zoom.